I've spent a lifetime exploring the far corners of our planet, yet the ocean remains its greatest, most profound mystery. It covers more than 70% of the Earth's surface, a vast, blue expanse that holds secrets we are only just beginning to comprehend. It is a world of breathtaking beauty, but also of immense and sometimes terrifying power. For millennia, we have been drawn to its shores, sailed its surfaces, and dreamed of what lies in its unplumbed depths. We tell stories of its wonders and its dangers, tales passed down through generations of seafarers and coastal dwellers. Today, I want to take you on a journey into this enigmatic realm. We will venture far beyond the familiar shores, into a world governed by forces that can defy our understanding. We will explore phenomena that have puzzled scientists and inspired legends for centuries. From strange, unexplained objects resting on the seabed to colossal whirlpools capable of swallowing ships whole, the ocean is a theater of the extraordinary. It is a place where the rules of the world above often do not apply, where light behaves in peculiar ways, and where the water itself can take on forms that seem to belong to another planet entirely. Join me as we unravel some of the ocean's most captivating mysteries. We will investigate anomalies that challenge our perception of history, witness the raw power of nature in its most dramatic displays, and learn to read the subtle signs the ocean gives us. This is not just a journey of discovery about the sea, but about our own planet and the incredible, often hidden, forces that shape it. The ocean has stories to tell, and if we listen closely, we might just begin to understand its language. It is a journey that promises wonder, awe, and a deeper appreciation for the wild heart of our world. Our journey begins in the cold, dark waters of the Baltic Sea. In 2011, a team of Swedish oceanographers, the Ocean X team, were using sonar to search for shipwrecks. Instead, they found something that defied all logical explanation. There, nearly 300 feet below the surface, their screens displayed a massive, perfectly circular object, some 200 feet in diameter. It appeared almost man-made, with features resembling ramps, stairways, and other strange, geometric structures. It was an anomaly so bizarre, so out of place, that it immediately captured the imagination of the world. What could this strange formation possibly be? The theories that emerged were as vast and deep as the ocean itself. Some suggested it was a remnant of a long-lost ancient civilization, a kind of underwater Stonehenge. Others, drawn to its disc-like shape, speculated that it was a crashed, unidentified flying object, an extraterrestrial craft that had met its end in the icy depths centuries ago. More grounded scientific theories proposed it could be a rare type of natural rock formation, a glacial deposit shaped by the immense pressures of the Ice Age. Yet none of these explanations seemed to fit perfectly. Divers who approached the object reported that their electronic equipment, including satellite phones and cameras, mysteriously failed when directly above it. To this day, the Baltic Sea anomaly remains one of the ocean's most compelling unsolved mysteries. The high cost of further expeditions, coupled with the challenging conditions of the Baltic, has left the object largely unstudied. The samples recovered were inconclusive, showing signs of both volcanic rock and materials not native to the region. It sits there now, in the silent darkness, a monumental question mark on the seabed. It serves as a powerful reminder that even in waters we consider familiar, there are secrets that we may never fully unravel, mysteries that continue to challenge our understanding of the world beneath the waves. Long before modern navigation, ancient mariners spoke of sea monsters and terrifying abysses that could swallow a ship whole. Among the most feared of these legends was the maelstrom. These are not mere myths. They are very real, immensely powerful whirlpools formed by the confluence of strong currents and tides. The Vikings, masters of the northern seas, knew to fear them. They spoke of the Moskstraumen, a ferocious maelstrom off the coast of Norway, as a gateway to the underworld, a force of nature so great that not even their sturdy longships could hope to escape its grasp. Its roar could be heard for miles, a constant, menacing growl from the deep. A maelstrom is created when tidal currents are forced through narrow straits or around underwater topography, creating a vortex of staggering proportions. The water can spin at incredible speeds, creating a deep, funnel-like depression in the ocean's surface. For any vessel, even a modern one, getting caught in such a phenomenon is a perilous ordeal. The sheer force of the rotating water can pull a ship off course, spin it uncontrollably, and in the most extreme cases, drag it beneath the waves. The danger is not just the downward pull, but the chaotic, unpredictable currents that can smash a vessel against hidden rocks or tear it apart with sheer hydraulic force. Even today, with our advanced ships and satellite navigation, these powerful oceanic features command respect. Captains meticulously chart their courses to avoid the known locations of major maelstroms, such as those off Norway, Scotland, or Japan. They are a visceral demonstration of the ocean's raw, untamable power. Maelstroms remind us that despite all our technology, we are still subject to the whims of the natural world. They are a living link to the fears of ancient sailors, a swirling, chaotic testament to the fact that some parts of the ocean will always remain wild, dangerous, and profoundly awe-inspiring. In the vastness of space, black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. It seems a concept confined to cosmology, yet our own oceans harbor a remarkably similar phenomenon. Scientists have discovered enormous, swirling eddies or vortices that behave in much the same way. These are not vortices that pull things downward like a maelstrom, but rather self-contained pockets of water that trap everything within them. They are, in effect, oceanic black holes, moving islands of water that refuse to mix with their surroundings. These oceanic eddies can be colossal, spanning up to 100 miles in diameter. They are formed by the complex interplay of ocean currents, temperature differences, and salinity levels. Once formed, they create a boundary so distinct that the water within the eddy does not interact with the water outside it. They can drift for months, even years, carrying with them a unique ecosystem. Plankton, marine life, and even pollutants and debris that wander into the eddy become trapped, transported across vast oceanic basins as if in a moving container. This has profound implications for understanding the distribution of nutrients and life in the sea. The danger of these black holes is not to ships in the same way as a maelstrom, but their existence presents a different kind of challenge. Their ability to trap and transport material means they can move oil spills or harmful algal blooms over huge distances, creating environmental hazards far from the original source. For marine animals, being trapped inside one could mean being carried far away from their natural feeding grounds or migration routes. These massive, silent, and invisible structures are a testament to the complexity of ocean dynamics, a hidden architecture that governs the flow of life and matter across our planet's blue heart. There are moments in nature so fleeting, so rare, that to witness one feels like a privilege. The green flash is one such phenomenon. It is an elusive emerald spark that can sometimes be seen just above the sun at the precise moment of sunrise or sunset. For centuries, sailors and coastal dwellers have spoken of it, some believing it to be a good omen, others a myth. It is not an illusion, but a genuine meteorological optical event, a final, brilliant greeting or farewell from the sun as it dips below or emerges from the horizon. The green flash is a product of our own atmosphere acting as a prism. As sunlight passes through the layers of air, it is refracted or bent. Different colors of light bend at slightly different angles. When the sun is very low on the horizon, its light has to travel through a much greater thickness of atmosphere. This disperses the colors, much like a prism splits white light into a rainbow. For a brief moment, as the top edge of the sun disappears or appears, the shorter wavelengths of light, green and blue, are the last to be visible. Because blue light is scattered more easily by the atmosphere, which is why the sky is blue, it is the green light that often makes it to our eyes in that final, dazzling flash. To spot it requires a very specific set of conditions. You need a clear, unobstructed view of the horizon, typically over the ocean, where there is no haze or pollution. The air must be stable, without too much turbulence. You must look at the very last sliver of the sun as it vanishes, or the very first point of light as it appears. It lasts for only a second or two, a tiny, brilliant burst of green against the twilight sky. It is a magical, almost ethereal sight, a perfect alignment of physics and timing. Witnessing it is a reward for patience, a reminder of the subtle and beautiful secrets the natural world reveals to those who take the time to look closely. The ocean can change its color in the most dramatic and sometimes sinister of ways. One of the most striking examples of this is the phenomenon known as a red tide. The water for miles around can turn a deep, murky red, resembling blood. This is not a chemical spill or some supernatural event, but a biological one. It is an algal bloom, a sudden and explosive population growth of microscopic algae, specifically a type of phytoplankton called dinoflagellates. Under the right conditions, warm surface temperatures, high nutrient content, and low salinity, these tiny organisms multiply at an astonishing rate. While some algal blooms are harmless, many red tides are profoundly dangerous. The specific species of algae that cause them often produce potent neurotoxins. As fish and shellfish filter the water for food, these toxins accumulate in their tissues. This can lead to massive fish kills, with thousands of dead fish washing ashore. For marine mammals, sea turtles, and birds that feed on these contaminated organisms, the result can be paralysis and death. It is a devastating chain reaction that can cripple an entire coastal ecosystem for weeks or even months. The danger extends to humans as well. Eating shellfish harvested from an area experiencing a red tide can lead to serious illnesses like paralytic shellfish poisoning, which can be fatal. Even simply breathing in the sea spray near an affected beach can cause respiratory irritation and asthma-like symptoms as the toxins become airborne. Red tides are most common in coastal areas like the Gulf of Mexico, California, and parts of Asia. They are a stark and vivid illustration of the delicate balance of marine ecosystems and how a change in conditions can unleash a silent, toxic plague upon the waters. Deep beneath the ocean's surface, the same geological forces that shape our continents are at work. Here, submarine volcanoes erupt, not into the air, but into the crushing pressure of the deep sea. These eruptions are unlike anything on land. The intense pressure of the overlying water can suppress explosive activity, leading to massive flows of pillow lava that cool rapidly into bulbous, rounded shapes. However, when an underwater volcano is closer to the surface, the encounter between molten rock and cold seawater can be extraordinarily violent, creating colossal explosions of steam, ash, and volcanic gases. These shallow water eruptions pose a unique set of dangers. They can generate localized tsunamis, powerful waves that can devastate nearby coastlines with little warning. The release of toxic volcanic gases can create dead zones in the water, suffocating marine life. For ships, the risks are immense and unusual. The eruption can release so much gas into the water that the density of the water is significantly reduced. A ship sailing into such an area can lose buoyancy and sink suddenly, as if the sea itself has turned to foam. Furthermore, the abrasive pumice and ash ejected can damage hulls and clog engine intakes, disabling a vessel in a highly volatile area. Yet, from this destruction comes creation. Over time, the lava and ash from these volcanoes build up, eventually breaking the surface to form new islands, like Surtsey, off the coast of Iceland. And on existing coastlines, the volcanic material can be broken down by the waves to create something of unique beauty: black sand beaches. The dark basaltic grains are a direct legacy of the fiery heart of the planet, meeting the cooling embrace of the ocean. These beaches are a stunning reminder that the seabed is not a static, silent place, but a dynamic and powerful landscape of creation and destruction. The surface of the ocean is rarely still, its waves usually moving in a single, predictable direction. But sometimes, a far stranger and more dangerous pattern emerges across seas. This phenomenon occurs when two separate wave systems, traveling from different directions, meet and interact. The result is a chaotic, checkerboard-like pattern on the water's surface, with steep, pyramidal waves that rise and fall with unnerving abruptness. It is a visually striking sight, but one that conceals a significant peril for anyone on or in the water. Cross seas, also known as a squared sea, typically form when waves from a distant storm system continue to travel and then intersect with the local waves generated by the current wind. For example, a groundswell from a storm hundreds of miles away might roll in from the southwest, while local winds create a chop moving from the northwest. Where they meet, their energies combine and interfere, creating peaks and troughs that do not follow the rhythmic pattern of a normal swell. It's a disorienting and unpredictable environment, a liquid landscape of sudden peaks and deep square-shaped holes. For swimmers, this can be incredibly dangerous. The chaotic motion makes it difficult to stay afloat and can quickly lead to exhaustion and panic. Small boats are particularly vulnerable. A normal wave lifts a boat in a predictable way, but a cross-sea can strike a vessel from multiple directions at once. A wave might hit the bow while another hits the beam, leading to a violent rolling and pitching motion that can easily capsize a smaller craft. Even larger ships can be put under immense structural stress. Cross seas are a stark reminder that the ocean's surface is a complex canvas, painted by winds and storms from across the globe. A walk along the beach after a storm often reveals lines of white, frothy foam deposited by the high tide. This is sea foam, a common and usually harmless sight. It is, in essence, the ocean's cappuccino. It's formed when the water is agitated, particularly by breaking waves, which churns up dissolved organic matter, proteins, fats, and other compounds from dead algae and marine life. This organic material acts as a surfactant, or foaming agent, much like soap. Air is mixed into the water, creating bubbles that stick together, forming the foam we see along the shoreline. In most cases, sea foam is simply a sign of a productive ocean ecosystem, rich in the microscopic life that forms the base of the marine food web. It can smell a bit fishy or briny, but it poses no threat. Children often play in it, and it dissipates quickly as the tide recedes and the sun shines. However, under certain circumstances, this innocent-looking foam can become a vessel for danger. When it forms during or after a large, harmful algal bloom, like a red tide, the foam can become highly concentrated with the toxins produced by the algae. This toxic foam presents a significant health risk. The churning action of the waves effectively aerosolizes the toxins, and the wind can carry this contaminated spray far inland. Inhaling these aerosols can cause severe respiratory problems, particularly for those with pre-existing conditions like asthma. In some rare extreme events, massive foam tsunamis have occurred, where gale-force winds whip up enormous quantities of foam, blanketing entire coastal towns. This foam can be thick enough to hide dangers on the ground, and if it is derived from polluted water, it can carry not just natural toxins, but industrial pollutants as well, turning a seemingly benign natural event into a serious environmental hazard. Rivers flow to the sea. It is one of the fundamental rules of our planet's geography. Yet, there are rare and spectacular occasions when this rule is broken, when the river appears to flow backwards, upstream from the ocean. This is a tidal bore, a remarkable phenomenon where the leading edge of an incoming tide forms a wave or series of waves that travels up a river or narrow bay against the current. It is a true tidal wave, not to be confused with a tsunami, and it is a breathtaking display of the moon's gravitational power. A tidal bore occurs only in specific locations around the world where the conditions are just right. The river must be relatively shallow, with a wide, funnel-shaped mouth that narrows as it goes inland. The tidal range, the difference between high and low tide, must also be exceptionally large, typically more than 20 feet. As the massive volume of the incoming high tide is forced into the constricting river channel, the water piles up on itself, forming a distinct, steep-fronted wave that powerfully surges inland, often at considerable speed. The sound can be immense, a low roar that announces the bore's arrival long before it is seen. While spectacular to watch, and even a famous challenge for surfers in places like the Amazon's Pororoca or the Severn Bore in England, these events are not without risk. The force of the wave can be immense, capable of sinking small boats moored in the river and dramatically eroding the riverbanks. The sudden and rapid rise in water level can catch people and animals by surprise, flooding low-lying areas in a matter of minutes. A tidal bore is a powerful, almost primal event, a dramatic clash between the river and the sea, where, for a brief and glorious moment, the sea always wins, reminding us of the immense and far-reaching influence of the tides. The beach is, for many of us, a place of relaxation and joy. But the ocean is a dynamic environment, and it is vital to know how to read its signs, particularly those that signal impending danger. One of the most critical warning signs of all is for a tsunami. If you are at the coast and experience a strong earthquake, that itself is the first and most important warning. But the ocean provides another, more subtle clue. Just before a tsunami arrives, the water at the shoreline may suddenly and dramatically recede, exposing the seafloor far beyond the normal low tide line. This is called drawdown. This strange and eerie sight might tempt the curious to venture out and explore the newly exposed seabed, to look at the stranded fish and shells. This is a fatal mistake. The drawdown is the trough of the colossal tsunami wave, which is following close behind. The sea has not vanished. It has simply pulled back to gather its strength for a devastating surge inland. If you ever witness the ocean receding in this unnatural way, you must not hesitate. Your only response should be to turn and move to the highest ground you can reach, as fast as you possibly can. Do not wait for official warnings. The ocean itself has given you one. There are other, less dramatic, but equally important signs. Rip currents, which are responsible for the majority of lifeguard rescues, often reveal themselves as a channel of calmer, choppier water, breaking the pattern of incoming waves, sometimes with a different color. Unusually colored water or large numbers of dead fish can signal a harmful algal bloom. And a sudden change in the sound of the sea, a roar where there was once a gentle lapping, can indicate a significant change in conditions offshore. Learning to read these signs is not about fear, but about respect. It is about understanding the language of the ocean, so that we may enjoy its beauty while remaining safe from its immense power. Our journey through the ocean's mysteries has taken us from the silent, dark floor of the Baltic to the sunlit, shimmering surface where green light flashes at dusk. We have witnessed its power in the terrifying spin of a maelstrom and the relentless surge of a tidal bore. We have seen its capacity for strange beauty in the creation of black sand beaches and its potential for danger in the deceptively lovely crimson of a red tide. Each phenomenon, whether explained by science or still shrouded in mystery, speaks to the incredible complexity and dynamism of our planet's oceans. They are not just vast bodies of water, but living, breathing systems with a character and a power all their own. What becomes clear is that our relationship with the ocean is one of perpetual discovery. For every question we answer, the sea poses a dozen more. It is a frontier that lies not in the distant stars, but right here on our own world, a place of immense biological diversity, geological activity, and physical forces that we are only just beginning to map and understand. The Baltic anomaly sits in darkness, waiting for a future expedition to reveal its secrets, a potent symbol of all that we have yet to learn. The ocean guards its secrets well, revealing them only to the patient, the curious, and the brave. And so, the next time you stand by the shore, I hope you see it with new eyes. Look for the subtle signs, listen to its many voices, and feel the immense history and power contained within every wave. The ocean connects us all, and its health is inextricably linked to our own. It is a source of life, a driver of climate, and a realm of endless fascination. Our exploration of it is a journey without end, and perhaps that is its greatest gift to us, the promise of infinite wonder, and a constant, humbling reminder of the grandeur of the natural world.